Starlight, star bright, first star I see tonight. I wish I may, I wish I might, have the wish I wish tonight. First star? Have you ever noticed or wondered why some stars are easier to see than others? Have you ever noticed that some of the stars seem much brighter than others, and some of them are really hard to see? Today, we're going to explore star brightness. Specifically, we're going to look at how the differences in how bright a star appears is due to how far away they are from us. By the end of this video, you'll be able to use evidence from this modeled experiment to support an argument that distance affects apparent star brightness. So, let's make sure we are ready. You're going to do an experiment today, so what I'd like you to do is pause this video and take this opportunity to collect your materials. You will need 2 identical flashlights of the same battery power, a pencil and paper with a T-chart that has these 2 sides ready. One side will be labeled diagram and the other side will be labeled conclusion. And a passion for science. Let's put our scientist hats on and do some investigating. Okay, do you have your materials? Great. Before we get started, let's make sure that we are in a learning zone that is distraction-free. How about we put away our cell phones and our tablets, turn off the TV, that way we don't have any distractions while we're learning. Are you ready? Let's get started. Okay, so some questions that we want to ask ourselves while we are conducting our experiment today are, how does distance affect the appeared brightness of stars? How can we use a model to explain how star brightness and distance are related? Is the only thing that affects an object's brightness the amount of light it gives off? For example, if I did not have identical flashlights and one of my flashlights had maybe bad batteries, the other one gave off really great light, maybe because it was brighter, would they still appear to be the same brightness regardless of how far or close they are? In other words, is it only an object's intrinsic brightness that affects its apparent brightness? Wait, what? Intrinsic what? Apparent brightness? What is intrinsic brightness and apparent brightness? And what is the difference? I'm glad you asked. Intrinsic is something that belongs to a person or a thing by its very nature and not for any other reason. It's built in. So, for example, dogs are intrinsically loyal. Our dogs love us and they are loyal to us because that is part of who they are. Even though they love to get treats and cuddles, they would be loyal to us even if they didn't get those things because it's part of their nature. Loyalty is intrinsic to them. Intrinsic brightness is how bright something is by its very nature. The intrinsic brightness of a star is how much light it gives off and how bright it is regardless of anything else. On the other hand, the apparent brightness of a star is how bright it appears to us. The apparent brightness of a star can be affected by many things, including how large it is, but it can also be affected by how close or far it is from us. Let's take the sun, for example. The sun is a star that appears larger and brighter than other stars because it's closer. The sun is our neighbor, but some stars, most stars, are really far from us. Stars that are closer to Earth can appear brighter than stars that are farther from Earth. Let's investigate that argument. As we conduct our experiment, I want you to use the T-chart that you created to collect data. Please draw a picture of what you are seeing in this experiment on the left side, labeled diagram. Then, on the right side, I want you to write whatever conclusion you draw from that evidence. One sentence is just fine, but I want you to use our new vocabulary words of intrinsic brightness and apparent brightness. And it's going to sound a little something like, when 2 stars are the same size, they have blank. This T-chart is what we're going to use to decide if we're making good learning progress. We're going to do the flashlight experiment now. As you notice, they're the same flashlight, identical brightness. And when we shine it on the surface, which is basically Earth, right? They're the same brightness, same distance, same size, same brightness. Now, go ahead and pause the video and draw on the left side of your T-chart what you saw. It might look a little something like this. Now, pause the video again and write a conclusion sentence on the right side of your T-chart. Maybe something like, when two stars have the same size, they have blank. Remember, I want you to use your new vocabulary words of intrinsic brightness or apparent brightness. Okay, great. Now we're going to do the experiment again. One of the flashlights we're going to put at the same distance from Earth, and the other flashlight we're going to put far away. Notice anything different? As we move one of the flashlights of identical size and brightness closer to the wall, it appears brighter, whereas the flashlight we moved farther away from the wall appears dimmer. Let's pause the video and draw that on our T-chart along with the conclusion sentence. It sounds something like, the closer a star is to Earth, blank. So, considering what we have observed in our experiment and the evidence we have collected on our T-chart, what would be your final conclusion? A question I want you to ask yourself, go ahead and pause the video, is, or you can ask your learning partner or your parent, whoever's with you, learning with you. As you formulate your conclusion, how does your conclusion support the argument that the difference in the apparent brightness of the sun compared to other stars is due to their distances from Earth? I observed that when we hold these identical flashlights at different distances, they have different apparent brightness. So how does that apply to our sun compared to other stars? Which flashlight do you think would be our sun, and which do you think would be the other stars? Now that you've considered and talked with your partner, pause this video again and write your final conclusion using your new vocabulary words. At the bottom of your T-chart, go ahead and write one sentence or two, maybe sounding something like, I observed that distance affects a star's blank. Hint, use your new vocabulary word. Because blank. If you're not able to put your thoughts into words, then feel free to turn your T-chart over and draw a picture. But make sure that it helps us to understand why the sun appears brighter than others. Well, my scientist friends, I hope you enjoyed this experiment, and I hope it has sparked more questions, more curiosity about the universe and its stars. Remember, questions come from curiosity, and that is the driving force behind science. Stay curious and stay exploring.